Yes. So the first thing here I want us to look at is the objective of this workshop. The objective is for you to conceptualize statistics. My name is Clement Dolapo, a consultant public health physician, and I think most of you know me, and a statistician. So the objective of the series is for us to conceptualize statistics, to be able to understand statistics and see the way you are seeing somebody physically, you're able to see statistics. There's no big deal about statistics. So it's a branch of mathematics. It's a formal science, and you discover that the knowledge of statistics is bimodal, just like that of mathematics. What it means that you have two sets of people that know it very well and people that don't know it. So it's difficult for you to say you're an average person in statistics. It's either you know it or you don't know it. The people that know it, they know it more than above average. The people that don't know it, they are below average. So that's just it. And why? Why is it that we have a lot of people that are very intelligent, even professors in their field, they're very intelligent. They don't know statistics, they don't understand statistics. Is it that they are very intelligent? It's because the difference between the people that know it very well and people that don't know is the secret. The people that know it very well have the secret, and that is what I actually give out to people. So I try to demystify statistics so that it becomes simple. It's just for you to, it will stimulate your interest. So the first thing is for you to conceptualize statistics. The second one is to learn and understand statistics without being bogged down in the equation. So most of the time, my statistics, even in the class and the practical session, you play down on equation because equations are just model developed by intelligent people. People that have already done, they understand, they just felt, okay, in something like mnemonics that people can just cram if you don't want to, since majority don't know it, just cram it and it give you the formula. It give you, once you just slot in the value, that is the equation, the formula. So actually, it's the people that understood statistics that created the formula. So when you understand the statistics from the basics, it's not you even need the formula. You don't need to, even you can even write the formula. Some of the formula you think that is difficult, but by the time you understand, you know the logic. And with the advent of computer, who solve statistics with HANA? You want to do your project? Who solve statistics by writing equation? No. But the logic behind all this thing for you to know the science behind it. So the third one is understand why and how to determine sample size. But those one, that one I remove it from this from our timetable. The reason being that most of you are MP, people have taught in MPH and determination of sample size. During your research method, you are supposed to know that. That's why, because it may take our time, remove it from the series. Normally, I do my workshop, I include that because we can, part of the issue, many people, when the reason many people see statistics, the major number one reason people call statistician is they want to, at the inception of their work, they want to determine the sample size. It's very, very important. And the somehow, it has effect on the type of analysis you do. If your sample size is small, the study design also, they affect, though I've removed both samples and study design from this workshop base, we still say something about study design because there's no way you can run analysis, know the right analysis to do without understanding the sample and the study design. Choose the appropriate statistical test during data analysis. How will you sorry, I but I was just logged out. Yeah, I'm back now. Let me be sure that the recording is. So sorry for that. So choose appropriate statistical test during data analysis. Then use statistical package to analyze data. That's the essence of the workshop per se, using SPSS. Understand how to present and interpret results. At least we look at the output and see how we interpret the result. But before we go into the basic concept of statistics, the first thing I want us to look at is the logic of scientific reasoning. As a scientist, how does statistics help you? How Do you understand? Because you get to understand from this that statistics is the technology of scientific method. And that's the essence of that. It's a very short one for that logics of scientific reason. I don't want to waste time because we have much to cover. So if you have question, what you do help me do is is to type chat. So once I go there, look at it, I can respond if you chat. Because if I ask you to be listening, though we don't have much time, but if there is need to elaborate more, you may have to raise your hand. But if you have a question, just chat. Now, science use in some of my slides, most of my slides rather, you will see some of these maxims. Some of those maxims were written by myself, some were quoted from other people. Like for this one, science is built up with facts as a house stone, but a collection of facts is no more a science than a heap of stone is a house. So if when we say science, if we just gather facts, data rather, well, we can call it facts, data, and it's not really analyzed, you won't be able to bring knowledge out of it. It is when you analyze it, you interpret, now, okay, what does that mean? So just having data does not make any build a house. Imagine you want to build, just put all the granite, everything, cement, everything there. Yes, you have spent money to bring them, but you have not built a house. Until they are arranged in a systematic manner, you cannot have a house. So that is how what statistic is to science. So you gather your data, it's the statistic that helps you make meaning before you can interpret and produce knowledge out of it. The purpose of science is to uncover truth. Well, don't ask me for that because for the when we talk about the holy book now, we tell you that truth is different. It's only God that knows the truth, which is true. But here, what just mean that what works, what does not work in certain situations. That's what we mean by truth here. Now, two tools a scientist use. Are you as a scientist, you use two tools to know what you know, to know your world, the material world. You know, use two tools. First one is your senses, the five senses, then the ability to reason. So you receive stimulus from with the five senses, you now reason it out. So just like you collect data with the five senses, then reasoning it out, that's the domain of statistics. That's why you need to say whatever information you have captured through your senses, how do you reason it out to make meaning? And that is, you need statistics. So let's look at two types of relationship between the scientists and the world. Let's try to understand two types of relationship between scientists' mind and the world. Look at this is it picture of figure now. You will see that you have at the top you have observation, at the bottom you have general theories, and you have arrow. No, the one that goes up from general theory to observation is called predict. The one that goes down from observation to general theory is infer. So the predict is deduction, and infer is induction. So what I just wanted to see there is that any research scientist carry out, they fall into these two categories. He said that before people think, people like in those days, the scientists, they believe that the scientific method is rooted in you guessing. You first of all guess that, oh, the scientists will guess, make a hypothesis. The guess, they call it intelligent guess, hypothesis. Then you now try to gather data, carry out your research to gather data to prove if your guess is true or not. If the guess is true, that's you now say, okay, it's strengthened, it may become theory. If another person carry out the same thing over and over, the theory is now become principle. After a while, like for the gravitational law now, the gravitational, the force of gravity have been studied over and over, it has become law. From hypothesis to theory, theory to principle, principle to law. But if you are observation, the hypothesis is not true, you can modify the hypothesis and carry out the experiment also. So this process of trying to starting with theory, you start with theory in form of hypothesis, you prove if it is right or not. That's what you are predicting. Because you're already, when you say you are predicting, you have something in mind, you are targeting. So that process called deduction. Deduction means that you have a theory, you have an hypothesis in mind, a theory in form of hypothesis you want to prove through your study. So you may prove it right or wrong. So whatever generalization, whatever you're going to say, oh, it is true, there's an association between teenage pregnancy and socioeconomic status, for example, you are predicting in this situation now what the statement is what we call deduction. But after for some time, scientists thought that that was the only way, that was the only scientific method, until intelligent people came up and said, look, even that observation itself is a form of scientific method. For you to guess, just guess. Just like, for example, Galileo or Newton. Newton. So please, so you have to be muted. Yaro, mute, please. So, is it Newton? He saw that a fruit fell, and answer. He said there must be something. There must be a force. He now made that hypothesis that there should be a force that make. Why didn't the fruit go sideways or upward? Make it to go down. There must be a force. If you look at it now, that guess that there must be a force. You carry out many experiments to validate, to prove the gravitational law. But the scientists are saying that even further observation that person, for him to say, okay, look, that observation is made that this fruit fell down. For him to be able to make that observation is a scientific method. So in a situation when you make an observation, it makes you to not generate it, because it was the observation you made about the fruit falling that make you to think there must be a force, something responsible for any object to go towards the head. So in that particular observation is what we call induction. Whatever the conclusion he made is induction, because he has inferred. So what happened? He moved from observation to theory. From observation, he was able to develop hypothesis, which we also call theory. Because when you want to test a theory, you call it hypothesis. Tested theory is a tested hypothesis is theory. So for the person to just make an observation, for example, now as a health practitioner, now you may see that here maybe you have a particular operation where you are dealing with adolescent health. Who is making noise? Please mute. I didn't want to mute people immediately, because when I was doing it, I would have said, okay, mute everyone. But I wouldn't know, maybe it will not allow the person to unmute himself. I don't want to control somebody. But let's behave ourselves. So mute until you want to talk. If you want to talk, you can unmute. If you have a question you want to tell me, so you can unmute. I don't know who is this person that is disturbing the class. So I will have somebody to, if you disturb the class, I will knock you out of the class because you are disturbing others. I just it. Okay. Yes. So now, for example, you have an office now when you deal with adolescent health. You now discover that some people, for some time now, people have been coming to your office, say the issue of adolescent pregnancy, teenage pregnancy coming. You now make an observation. It's like this for the last 3 months now. Most of these people have had about 15 cases of this adolescent pregnancy, teenage pregnancy, and these cases 12 or 14 or 13 out of these 15 is from low socioeconomic class. So, it's easy for you to say, it's poverty that's causing this thing. Can you see now? From your observation, that type of observation is what we call spurious observation. Spurious means that it's not it's not systematic. But if, for example, now, that's a form of observation. But for systematic observation, you may say, I want to know pattern of driving in Abuja. Pattern of driving in that situation, you don't have in mind that, what accident? No, you just want a pattern of driving or descriptive study. You may want to get information about, you have a license, what is the age, until you start driving, what is the age of that person, what is the sex of that person, what type of car, many questions you have. By the time you do your analysis, you may not discover that the people that don't have license, they are more likely to have accident. They maybe men are more likely to drive roughly. No, all those things, you begin to looking at association between two different variables. You are creating theory from observation. It's a systematic observation. It's not a spurious observation because you design your questionnaire to carry out the study. But the issue there is that you now make some generalization. Women are more likely to do this. Young people are more likely to have accident, to hit people. You create a lot of theory out of the study. That is, you are moving from observation to general theory. That is induction. So in that way, it can be spurious, it can be systematic. Spurious just means that the example I've given about teenage parents, somebody just see that, just discover, he just reason it out. He now want to study it. So by generating theory from general observation, that is induction. Then if somebody now pick up, oh, is it true that low socioeconomic class are more likely to have teenage pregnancy? That is true that there's an association between teenage pregnancy and socioeconomic status. If you now go and you now state that hypothesis and now go and carry your work and now prove either it's wrong or right, that is deduction. So any research being done in science, is said that induction or deduction. It falls into any of them. Both of them. So the scientific parallel grows based on this method, induction or deduction. Now, this one is just to give explanation to what I've just said. Inductive inference. Inference actually means generalization. Generalization you make from sample to the population. You know that most of the time, the population is so large, you cannot study the whole population, you take sample. When you take sample, what you get from the sample, you summarize. The summary you get, call it descriptive statistics. Descriptive statistics, because that is a summary, is statistic you got. You do your descriptive statistics based on the sample you have. So now, whether what you have gotten is the same thing with what is real, if you have taken care of everybody in the population. Instead of taking sample of 400 among 3 million people, if you take sample of 400, whatever you summarize, can it be the same thing if you have attended to all the 3 million? It cannot be. So whether what you have is close to or equal to what is the population is a matter of probability. And that is why you now do some generalization. You now want to say something about the population based on the finding from your sample, inference. So the same thing we have said that there are two approaches between in which the scientists understand the world, inductive and deductive. Whenever you make generalization, the generalization is either deductive or inductive, depending on which one you start from. If you start with observation to generate theory, you are made inductive inference, deductive inference rather. But if you inductive inference. But if you start with theory to want to prove, observation means you collect data. That's all. You start with theory, you make your observation, you want to collect your data. That is deductive inference. And just these are the. So now, I want us to quickly understand the concept of phenomenon. Theory can be used to describe observation. The observation are always exactly with them. This is due to error. Observation are not always exactly. So you may say, okay, you want to predict observation. The theory you may, this thing is like this. By the time you carry it out, you may not exactly get the same thing because of error. This is due to error. There are some error that are inherent naturally. If the observation are widely different from the prediction, the theory have to be abandoned or modified. That's what scientists have been doing all over the world, over the time. How do we differentiate the discordance between our prediction and the observation from the discordance due to error and inherent variability of the national phenomenon. What we are saying here is that naturally things vary. Even you now, for example, biological variable, social science variable, they vary a lot. While other physics, chemistry, they vary, but not as much as biological and social science. For example, now, if you say you do experiment, H, component of water, hydrogen and oxygen. If you do it in Nigeria, you give it the same thing. If they do the same thing in Canada, it will give the same answer. If they do it the same way, under the same condition. But that is physical science for you. But when we talk about maybe even the blood pressure in Nigeria and America may be different because our food, a lot of things affect our blood pressure. Our food, even if you take your blood pressure now, as you are seated, and after 2 minutes, take again, you will not get the same reading because inside you, a lot of things, changes are going on in the way that are you hungry or maybe you're just eating. A lot of things are affected. Look at HIV discrimination against HIV. Is it the same thing in Africa and America? No. Even in America, is it the same thing? Even in Nigeria, it's not. Is it the same thing in the north and the south? No. If you go to the same state, is it the same thing in the different local government? No. You go to the same local government, is it the same thing in different towns? No. Those are there are some variables that vary naturally too much, especially biological and social science variables. Yes, how do we differentiate the variation due to that natural inherent variation and the variation due to your error, if you are, due to the way you carry out the study? And that's the essence of the statistical test. It is by carrying out a statistical test, which is the test of non-hypothesis. So the variability of phenomenon is the need for statistical analysis. The reason for statistics is because of the variability of phenomenon. Phenomenon just means variable you are studying. If you say you want your weight, that weight of the baby, that's the phenomenon. If you want to say you want to know the anxiety, that's phenomenon. So when you talk about phenomenon, you just talk about the variable you are studying. If you got these variables vary, that is why we need statistics. So just like I've thrown light to this thing, behavioral and behavioral phenomena explained by using model. Now, the different phenomena available you are studying may be classified into deterministic or using deterministic or probabilistic model. I've actually explained it. When we talk about deterministic, we refer to variables that don't vary much. For example, in natural science like physics, chemistry, the variable don't vary much. For example, Bohr's law, Charles law, that talk about Bohr's law talk about pressure and temperature inverse proportion, while the other one volume and no pressure and volume rather inverse proportion. Bohr's law, Charles law, temperature and volume direct proportion. So you see that if you carry out the experiment anywhere in the world, it will give you the same thing. But it's not the same thing with biology, with social science variable. You call IQ, it's not the same thing. If you discrimination, stigma, it's not the same. Quality of head, perception on the way you perceive things vary a lot. So this one that don't vary, they follow deterministic model, while the one that vary a lot follow probabilistic. And that is the reason we actually need statistics because of the variation. You now discover that the biology and the social science variable research need statistics more than this other one. And that is why over the year, the people that developed statistics were biologists then and social scientists. Those are the people. If you heard of Fisher, they were geneticists. Fisher, Spearman, all those were biologists. Then you have some other social scientists. Hardly you see any physicists or chemists that develop, or they don't need it, like the biologists and the social scientists. And that's why most of the textbooks you see, if I said that, is tailored towards like biostatistics or tailored towards social science on statistics, because those are the field that develop statistics over the year. So statistical methods are objective methods by which group trends are abstracted from observation on many separate individuals. So more often than not, the researcher is not able to carry out observation on all the units constitute the population for cost and logistic reasons. We know that. So he or she can still conduct the research by examining a subset population sample by taking a representative sample, after which an extrapolation or inductive inference or is made from the result gotten from the sample to the population. The reliability of such inference or conclusion may be evaluated in form of probabilistic statement. That is why, remember, probability comes in. Statistics and probability, they go together. So in fact, statistical thinking starts with probability and probability. So because in statistical reasoning, we have inductive inference from the specific sample to the general population, statistics may refer to as the technology or scientific method. So before we now go to the basic concept quickly, is there any question? One or two questions? Let me check the chat box if you have dropped any question there. So I can't see. It's like no chat box, no question. If you can raise your hand if you have a question. You can raise hand and ask the question, maybe one or two, so that we proceed. So it's believe that you understood everything. Anyway, we have taught this thing in the class, so it should not be a problem. So we'll move to the next one. I believe you can see. If you cannot see the screen, you can let me know. I believe you can see. So let's, well, this is one of the basic concepts of statistics. Research and education are two ways of development, with research being the front way. All these things for us, some of you that were in the class, we have done all this, but just for us to rush through. So, relationship between research and statistics. Research is bigger than statistics. Statistics is just an instrument in research. Research is not all about statistics. But over the years, statistics is taking more prominent position in research. It's becoming more important and more important in research than ever. So that is why you see a lot of things hang to the extent that if you want to start your research, especially quantitative research, if you don't get statistician, you don't understand statistics from the inception, you may have problem. Even from the designing stage, you must get statistician involved so that you won't go and collect data that will be useless. Some people, the data they collected has nothing to do with their objective, has nothing to do with what they want to achieve. That's dead on arrival. But it takes statistical knowledge for you to understand that. So when you immediately see something, the message, how will you achieve it? When you talk about one objective, the statistician will look at what are the variables in his mind, what are the variables needed for this to achieve this objective. That's what will be coming through the mind of the person. So statistics is taking a prominent position in research. Research is the process of arriving at dependable solution to problem through plan and systematic collection, analysis, and interpretation of data. So it's about collecting, analyzing, and interpreting data to solve problems. Now, statistics has to do with collection, analysis, and interpretation of data. So you can use now. You know all the data that requires statistics. Like, for example, when you talk about qualitative research now, you collect data also. But the data is not that type of quantitative data. It doesn't require statistics. For example, focus group discussion, key informant interview, in-depth interview, all those ones, they don't require statistics. They are data also, they are qualitative data. But you will see, somehow, they have their usefulness. But for epidemiology, the number one method is the quantitative. Number one method, because the principle behind epidemiology is different. If that's where the evidence is different from social science, I'll be talking about biology and social science. Then why social science completely, even some of them will get involved in qualitative research. Therefore, epidemiology is both qualitative and quantitative, mostly quantitative. So that is why, and epidemiology is the most important subject in public health. Epidemiology is the most important subject in public health. And biostatistics is the foundation of the epidemiology. So the backbone of public epidemiology, the foundation of epidemiology is statistics. So this epidemiology is standing on statistics. It's based on statistics. And it happened to the epidemiology is not the backbone of public health. And the essence of public health is management. So that's what made those three courses important, the most important. The most important is epidemiology or statistics. Now, let's look at, so you can see the thing that is common here is data. Data. So from what you can just say, process of arriving at dependable solution through statistics, but you cannot say that because there are some aspects of research that don't use statistics. But over the year, even those ones that don't use statistics, they want to bring in. Everybody want to associate with statistics. For example, now in law, in their research, they don't do quantitative research. But later now they started saying that they get involved in quantitative research. So let's look at field of statistics, mathematical statistics, applied statistics. Mathematical just mean that when you just use mathematical model. While applied statistics is use that mathematical model in a particular field. So biostatistics is an applied statistic. Econometry is an applied statistic in the field of economics. So let's quickly rush through the basic concept. And I know that these are the things we have done before in the class. We rush through population and sample, variable data, measurement, observation. Why I do this, I want to rush through is that some people, they just manage to pass that time, so they didn't understand. And the issue is that whether these are the foundation. If you want to get to know what we are doing, all those things, by the time we start analyzing, if you don't even can differentiate between sample and data, it will be like as if you are gambling. So let's look at population. Population is a set of person or object. So if you don't want to say person or object, just say subject. Subject stands for person or object. So a set of subjects having a common observable characteristics. For example, height, weight. These are common observable characteristics. If you look at it now, to a researcher, you must have a group that, okay, this is what I want to know about them. Oh, is it hypertension? Is it their blood sugar? Is it their anxiety level? Is it depression? Is it hemoglobin level? Is it the use of uptake of HPV vaccine? Is it uptake of cervical cancer screening? Think of anything. That particular thing, characteristic you're looking for, they have it, you can observe. That's population. So that's what makes you to be different from other people in the Ministry of Women Affairs. They say population is a group of people living in a community. No, for a statistician and researcher, is a group of subjects with observable or measurable characteristics. Those group of subjects are actually called popular population. In some situation, the characteristics we are talking about you may not even need to access this group to get to observe. You may get to their record. For example, cancer registry, go to the hospital, record. So these people, they have already documented their record there. So the record is the population now. These people, they are not there. You can go to the record and take case note and study. That situation, the population you get there is not the people, human being or whatever, is the data. That's what we call statistical population. Population can be large, can be small, infinite, large, finite, small. There's no distinction between the but when you want to calculate sample size, statisticians come with the idea that any population at 10,000 or more is considered to be large, while anyone less than 10,000 is considered to be small, because it has implication. If you are doing something in the facility, now most of the time, it's going to be less than 10,000. But when you are doing any study in the community, it's going to be 10,000 or more. So can you see the logic? So it has implication when you are calculating sample size. Then the sample itself is a subset of population because population may be so large that you cannot attend to every subject. That's the essence of that of sampling, taking sample. Now, population, variable, and data. We have already said that a population is a group of subject or object with observable or measurable characteristics. These observable or measurable characteristics are the variable. And these variables are the vary from one subject to the other. So if you have any question, you can if you have any question, because I've finished with population and sample now, we are in variable and data. If you have questions, you can share. If you shout and you see that didn't respond, you can raise your hand and see. So you can raise your hands. Nobody shout here. Okay. Data. So we are talking about some variable now. Variable. Then data are value a characteristic can assume. For example, now sex is a variable, but if you say male, female, these are data. Data is a plural word. The value, the singular is datum. Because if you are doing statistics or research, you only deal with one person. Even when you deal with one person, you only deal with one variable. For example, now, even in case report, where it's only one person, you measure you know the age, sex, weight, blood pressure, a lot of things. So the value you are collecting from different variables make it plural. It becomes data. That's why the word datum is useless. So data is the value of variable. What variable are characteristic vary in value from one subject to the other. So if in this class now we are male, female, sex is a variable. But if it's only men something, there's no female, sex is not a variable, it's a constant. If you are doing something in an antenatal clinic or women or reproductive age or whatever, so sex is not a variable, it's a constant. Because among these people, this characteristic does not vary. It doesn't differ. But when you are talking about population, really, sex is a variable. Weight is a variable, height is a variable, it varies. The value varies from one person to the other. So think of anything, just like say, now is the name of any person, animal, place, or thing. Anything you can think of characteristics is a variable because the value will vary from one person to the other in most cases. Now, let's move on. The classification of variable now. So we have already said that the value variable now is the value of variable theta. Variable, something that characteristics that vary in value from one subject to the other. So whenever you can, this value you can give to a variable is number. It's different from when you cannot give number. For example, age, you say 34 is number. Sex, you say female is not number. If you code, say 1, 2, is that one is coding. But if there's a has to which religion, you say Islam. That is not a number. These are quality. But when you say how many children you have, you say 3. That is number. Can you see now? So whenever a variable can be given numerical value, it's a numerical variable. While the one that cannot be given numerical value is qualitative variable. So the numerical variable, we call it quantitative because number you can quantify. You can say, oh, this one, if this one say 2, you know that 2 and 4, there is different relationship between the 2, 4 doubles 2. So you'll be able to quantify. That's why it's either you call it numerical or quantitative variable. Now, in for the other one, the qualitative variable, because by the time you say, for example, sex now, you say this one are female, this one are male, it can handle categorizing them into 2. That's why they also call it categorical variable, because those values that are not their qualities, the hand of, for example, skin color. See, you can say light, chocolate, and dark. So you have categorized them based on the value into different categories. That's why they also call it categorical variable. Before we move further, it's good for me to first of all take you to the scale of measurement, as I usually do. This scale of it, how do you appreciate this variable? We already said that these are the value. We talk about the value of variable now. We classify them into quantitative and qualitative. Before we classify further, how do we even measure this variable as per statistically? It's not how do we measure them physically. We are talking of statistics. How do you appreciate it? We call it scale of measurement. How do you conceptualize it? They are conceptual scale. That is what will make you as a statistician to know, oh, which type of analysis can I do for this one? You in the realm of statistics, it's a conceptual scale. There are 4. It was first described by one Marcus Stephen Stanley in 1947. He now classified, categorized variable into 4 categories. And he described the scale of measurement using 4 different scales, rather. From the most simplest to the most complex. Nominal, what it just does is that, okay, these are the values of this variable. So the value, we end up categorizing them into different categories. But you cannot order them. You cannot order, for example, now, male or female. There's nothing that says male comes first before female. If for convenience, you can write female, alphabetical order, female, male. So now, for example, now, religion, Islam, Christianity, Hinduism, paganism, or whatever traditional religion in Nigeria, these are different categories. You cannot say rank, say let's rank them according to religion. No, you don't rank. The same thing with geopolitical zone in Nigeria or ethnic group. You have Asa, Igbo, Yoruba, Eshekiri, Bra, Marigi, who are those other people? Benue is talking about Idoma, Kanuri, all those. So you see that there are different categories. There's nothing like ranking. In Nigeria, where we just use Igbo Yoruba, we know that it's based on population, since the major one, and that major one, the two outside alphabetical order, Igbo, Yoruba, and that's it, the rest order. So just for convenience, there's no ranking, there are different categories, no ranking. But there are some variables that require ranking. For example, in the military, the different level, you can have major general, brigadier general, colonel, group captain, major, and then lieutenant colonel, lieutenant colonel, group captain, captain. You know, even in the medical profession, we have medical officer, we have house officer, medical officer, register, senior register, consultant. And you see, so different categories. And these different categories, they have ranking. You know that they are different categories, but you know that all animal equal, but some are more equal than the other. So you can rank them. The same thing in many professions. You can rank different categories. So there are different categories. This element of more than or less than is there. That is ordinal. Even the disease severity, moderate, mild, moderate, and severe. You can rank based on severity. You remember all the cancer, well differentiated, moderately differentiated. All those different categories is to rank. And but the problem there is that how much more, you don't know how much less. If you say major general is higher than brigadier general, then brigadier general is higher than colonel. How much higher? Is it the same distance between colonel and brigadier general and between brigadier general and general? You don't know. Major general, you don't know. It's just different category. You cannot quantify the gap between them. How much more is not there, and that's why you now go to interval. Interval scale, we give you different category. It will give you order. How much more, for example, now, if you measure somebody's temperature is 36, another person 38, another one 39. You know that 3 temperature now. You know that different categories of this temperature. You know that you can know that one is higher than the other. You will even know how much more. Because someone that have 36, you know that 38 is 2 times, 2 more, not 2 times, 2 more, 2 units higher than 36. 39 is 1 unit higher than 38. 39 is 3 units higher than 36. You know. So can you see now? You know different category. You can arrange them, ascending order or descending order. You even know how much more. That is the interval. But the only problem with that one, there's no true zero origin. True zero origin means that the attribute you are measuring with that interval, if the attribute is not there, it may not read zero. If it reads zero, it doesn't mean that the attribute is not there. For example, now, if you carry somebody, you want to weigh somebody on weighing scale, if the weighing scale is not 40, if you don't put anything, it should be on 0. If you put something on 1 kg, it should weigh 1 kg. You put 5 kg, it should weigh 5 kg. If you are 70 kg, you stand on it, you should be 70 kg. When you come back, you go back to 0. That shows that it has true zero origin. But in a situation where something is zero, you see a temperature, for example, what is the temperature of ice block? Is zero. Water freezes as a, well, it can be less than zero, but water freezes as a 0 degrees centigrade. And it doesn't mean that that's the temperature. For the fact that it's saying zero, doesn't mean that there's no temperature to measure. No, there's temperature to measure. It's just a stage. And that's why I brought all these things to explain. I think I've explained it before. Anytime you see, look at 3 different temperature scale. We have Kelvin, we have Celsius, we have Fahrenheit. You will see that, you see, we know that water freezes at 0. The same water boil at 100. The same 100 with degrees Celsius, the one in the middle. If you look at it, the freezing, the 0 in the Celsius scale corresponds with 273.15 in Kelvin scale. Then the 0 in Kelvin scale corresponds with minus 273.15 in Celsius scale. The 100 in Celsius scale corresponds with 373.15 in Kelvin scale. Now, let me just tell you something. You remember, most of you are scientists, you have science backgrounds. Only few people that have social science. It may find it difficult to understand. If you remember the kinetic theory of matter, matter is in a state of constant motion. What it means is that matter, even your body as you are seeing now, the molecules, they are moving, they are not static. Even the chair where you are seated, the molecules are vibrating, even they are not moving, they are not fully moving, but they are vibrating. It's water that gives it, explain it very well in every scientific book. It's water that is the commonest thing that explains that, the state of matter based on the kinetic theory. If the movement, if you supply it to water, it will boil, it will escape, it turns to gas. The water itself can freely move. It take the shape of the container and move freely. But when you supply it, it now begin to move vigorously, it turns to steam and escape. Can you see now? If you cool the steam, it come back and become water, a condensed will become water. If you continue freezing the water, it become block. Can you see now? Blocking in the water, it means that the thing is vibrating. When you have a solid now, the matter there, they are moving. Even though they are not moving from one place, they are vibrating. If you continue reducing the temperature until it reaches a state where all matter stands still, no molecule move, that is what we call absolute zero. Because the temperature, if there's no heat, kinetic energy, you cannot measure temperature. And the temperature, the thermometer, the measure is a degree of hotness or coldness of a particular body. So if at that level is 0, where there's no movement, kinetic theory is 0, the kinetic energy is 0, you cannot measure temperature. Temperature will be 0. That's how it's supposed to be. It's only Kelvin scale that have that true 0 origin. If you measure temperature through Kelvin, it says 0. It means that attribute you are measuring is not there. If the attribute is not there, it will measure 0. But it's not the same thing as Celsius and Fahrenheit. When it tells you that at absolute 0, which is supposed to be 0 degrees, 0 Kelvin, the Celsius is giving you minus 273.15. That shows that when the attribute is not here, it's not reading 0. When you come to 0 degrees centigrade, it gives you, whereas it's just a temperature. The attribute is there, but it says 0. So can you see now? So Celsius and Fahrenheit, they don't have true 0 origin, while Kelvin is the only temperature scale that have true 0 origin. And many other things we are mentioning. So well, there are few things. This centigrade and Fahrenheit is just 2 examples of few attributes that fall under interval. Most of the attributes we measure, apart from the ordinal, nominal, their ratio, weight, height, blood sugar, age. Think of many things you measure, even IQ, their ratio scale, because they have true 0 origin. I don't know if is there any question before we move further? Any question there? For example, now, okay, anyway, we'll come back to that. So let's come to, okay, the last one is ratio. And I've said it, ratio, you can know it has true 0 origin. So the ratio has all these attributes of nominal, ordinal, and interval, and something in addition. The interval has all the attributes of nominal and interval and something in addition. The ordinal has all the attributes of nominal and something in addition. So it's ratio that covers all. So it's from the simplest to the most complex. Now, when we now come back to our classification of what do I call it? A variable now. You will now see that if I ask you a question now, it is very clear that nominal or ordinal, they are for qualitative variable. That is categorical variable, because they don't have number. If you look at it, you see the nominal, ordinal. Why the other one, the quantitative, number. We have already said number. So sometimes we use number to denote, to represent ordinal variable. That one is just coding. When you say you use like SK, strongly disagree, agree, disagree, neutral, disagree, strongly agree. A scale of 1 to 5 or 0 to 4. The issue there is that it's just a convenience. Issue of convenience. That's not their real value. They don't have value. It's just coding. That's ordinal for you. So it doesn't mean that it's a quantitative variable. You just use that because it's a rank. You can just rank with number. Now, when we now come to a quantitative numerical variable, you may be thinking, why is it not interval and ratio? No, it's not like that. The way to classify, though we use interval and ratio as scale of measurement, but the way to classify it is that if something is number, the number can be whole number or decimal. If the number is usually the whole number, it's discrete. When it has decimal, it can have decimal. It may be whole number, it can also have decimal. It's continuous. For example, now, weight, height. Most of the time, you measure to the nearest, maybe meter or kilogram you are measuring. But the issue is that it may be 74 kilogram, 20 gram, plus this microgram. So you just approximate. So it actually has decimal. But if they have the number of children, you cannot say you have 2.5 children or 1.34 children. No, his whole number is either 1, 2, 3, something you count. So when you count something, it's discrete. But you measure something, is continuous. That's the difference. So the discrete variable are the quantitative variable that you can actually. So another way of explaining is that there are limited number of value in between two given value. Between 5 and 7, you have 5, 6, 7, or 7 in between. But if they say between blood pressure or blood sugar of 60 and 65, how many value? Will you say 5? No. Even between 60 and 61, you can have 60.12, 60.23, 3.45, infinite number in between two given value. That is a continuous variable for you. So most of the variable we measure in the biology, they are continuous variable. Most, not all. So that's a way. So you can see that way of classifying variable, quantitative, qualitative. There's another way, alternative way that make more statistical sense than the first one. This first one make it easy for you to understand. But this second one make more statistical sense. We usually start with the one that make it easy to understand. But we now come to the one that make more sense. So look at it. Variable can be that discrete or continuous. Is the continuous you have nominal, ordinal, and numerical. The meaning of discrete is that there are a distinct category. That's the meaning of discrete. Distinct category. So we have already said it before. We say discrete numerical. Even if you say number of children, you can say if you cannot in between 1 and 10, you can only have 1, 2, 3 up to 10. You can only have 2, 3, 4 to 9 between 1 and 10. Nothing more possible value in between. So that is why there are discrete categories. So if you look the nominal, ordinal, so they are distinct category. So the only difference that the one we call discrete here is discrete numerical. That is, it has number but still discrete. That's why we have numerical. Discrete numerical. In numerical is what you have here when we say quantitative, discrete, and continuous. It's discrete numerical. These nominal, ordinal, they are discrete also in the sense that they have distinct categories. Now, that's alternative way of classifying variable. I think the next thing we talk about is parameter and statistics. Parameter and statistics. Yes, parameter and statistics. So, parameter, when you summarize this concept of parameter and statistics, is very, very important. Which we'll start with. Yes, I think okay. It's so important to statistics that even the way you denote them, we use Roman figure and numeral letter, rather Roman letter, to denote statistics. Why Greek alphabet for parameter? So parameter, any summarization of element of a population. As if, for example, now you want to know weight. What is the average weight in Abuja of adult? If it's possible for you to measure the weight of every adult in Abuja, you will now add everything and summarize and calculate the average. That would be parameter. But we know that it's majorly is possible for you to all the millions of adults in Abuja. It's not it's difficult for you to measure everywhere. If let's say it's possible, whatever you get as you summarize is the parameter. But most of the time, what we do is to take sample, maybe 800, 400, and measure their weight and calculate the mean, summarize it. That mean for sample is called statistic. Statistic without S. Statistics with S is the subject. Or if this statistic without S is the plural form, it will have S. It will have S. But if it's singular, statistic without S. That's why they say, oh, infant mortality is a statistic. Maternal mortality, they say Nigerian statistics is not encouraging. They are talking of this because the way they calculated the infant maternal mortality ratio, all this one, is not every woman or every children that are in that category they consider in calculation. They have some site where they collect this data. It's just they take sample and they now summarize and I say, oh, this is our infant mortality. That's why we call it statistic. The actual real value, if let's say they can consider everybody in the population to calculate it to be parameter. So can you differentiate between parameter and statistics? The summarization of element of population is parameter. The summarization of the same thing sample is statistics. Because you as a researcher, you don't have access to the parameter. Because you cannot take care of attend to all the elements in the population, you cannot know the parameter. It's only God that knows it. What you can know is what you can get from your sample, which is in statistics. And the value you get will even depend on your sample size anyway. And that is why, can you see now? Look at here. Mean by X for sample by X. Mean in population is mu. S is standard deviation for sample. Rho is standard deviation for population. P is proportion for sample. While phi, you call it phi in Greek, is the proportion for the population. The small n is the sample size. N is the population size. Capital N is population size. So the last one is descriptive statistics and inferential statistics. If you look at it, in fact, the best way is this diagram. Now, if we already talked about population sample, sample is a subset of population. Now, parameter is the summarization you want to get for population. The sample, the statistic is the summarization you want to get for sample you got from sample. Imagine, example we are using here, let's say weight now. In the population you are involved, you want to study weight. You took sample, you cannot attend to all the whole population. When you measure the weight of the adult now, you calculate your mean to be 73 kg, but the mean in the population you don't know, which is questionable. Now, the descriptive statistic is the process from the point of collecting your data, collecting data onto the summarization, that is descriptive statistics. So we said statistics, the collection, analysis, organizing, analyzing, interpreting data is statistics. The aspect I have to do auto summarization is descriptive statistics. So the one that now involve you making inference, you want to know the value to project what the parameter in the population might be based on the statistic you got from the sample is differential statistics. Can you see that? And that is the one that involves all those statistical tests, hypothesis testing, to really know that. Because you want to know that what you have gotten from your sample, what is telling you, is it actually true in the population? How true it is? That's the essence of all those statistical tests. That is the realm of differential statistics. So inference, we already talked about inference the other time. Inference is the generalization you make. from the sample about the population. So when we say inferential statistics, so you want to generalize your statistic. That value you got, this what you got from the summary of the sample, you want to generalize it and now say what it may be, how it will look like in the population. That is inference. So that aspect of statistics is called inferential statistics. So it involves hypothesis testing and confidence interval. These are inspiration. And mind you, for you to do that, for you to actually make any sense between from your descriptive statistic about the inferential statistic, you need probability. That's why probability is more like a bridge in between descriptive statistic and inferential statistic. So that's why when you talk about descriptive, you have to understand probability before you can understand descriptive statistics. So I don't know, nobody has question. Is it that some people are sleeping? Any question? I didn't see anything in chat box. So
We are following, sir.
You are following?
Yes, sir.
Yes, sir.
Okay. I hope you are following. Now,
Yes, sir.
so no question because you are following and no question. Okay, no, if there's no question, some people they talk about the Quran. If that's the case, if there's no question, let me pause. Let me pause so that we can some of the talk that is not necessary because we may not want to watch the video. So those talk that are not necessary will not be captured. Yeah. So I try to share my SPSS environment, though this is a data set where we, if you want to open, I want to believe everybody know how to open SPSS. So the first thing is for us to, how do you create? I think we had a time, we had a session before we closed. Did you have one session that time or we didn't have any session on this SPSS stuff? Did you have session during your course?
No, sir.
We didn't have any session.
No, sir.
Okay, if that's the case.
No,
So,
we didn't, sir.
yeah,
No, sir.
Okay. If that's the case, now you can, if you want to open your SPSS, if you can click on the icon, it will open. No more than that, it will open you blank space. Let me open new. So you have blank space like this. You can see the blank space. So we want to quickly go through the SPSS environment. So everybody, you can do that now as you in your this. That's why I encourage you to use your laptop connected to the Zoom with your laptop because I even ask you to share it. That's the only way you can learn. So you can see it now. So this is SPSS environment. And this SPSS, you see grid line like that of Excel. They're different from Excel. So there are many windows. But when you open SPSS, it will open, for example, now, when you just open it, will open you the first window. This window is what we call data editor window. But if you have SPSS document, one thing with SPSS is very interesting is that even if you didn't go and once you have installed it, you have a document stored anywhere. You double click on it to open that document, SPSS document. It will open window SPSS window for you automatically. So in that situation, it will open two windows for you. It will open this window, which is the data editor's window. You will see your data there. It will also open you what we call viewer window, sort window. Believing that when you are running analysis, that's where your result will go into. But before we do that, this one I just open, though I open new, but I already have a window that I opened there. It has both window. I have already look at this SPSS document, which I open here. It has both via window and this thing. Can you see? I have to be sure that the way I'm moving, one thing with Zoom is that, I don't know. So what can you see now? Do you see any blanks? Is it blank space we are using, or it's not a blank space? Not really sure. Which
It's
one
not
you see?
blank.
I know what has happened. I have to reshare. Don't worry, I have to reshare. And this is a blank space. So you can see blank space now, right? Somebody chatted. I want you to be responding now, please.
Yes, sir. It's blank. It's blank.
Yes, sir, it's blank.
Somebody say I successfully downloaded, but it is not opening. I figure I need to install some app before. Which app? You have, if you have downloaded, you have not installed. I send you step for installation. If you have to follow the step to the letter, I'm sure those who that installed that and it was bad, but they have learned it. That I send the step for installing SPSS 25. It worked for this the same 27. If you follow it from beginning to the end, you install it. Because there are some tricks there. You know, it's not the license is crack. So more like a stolen goods. So you know the SPSS is very, very important, very, very costly. Nobody can buy it. It's very, very, it's the most costly statistical package. So what people do over time is to crack it. But the people that have this, or they are making it difficult for you to crack. There's still people to crack is not easy like before. That's why that step, I wrote the step for you, how you can install it. If you follow it to the letter, you'll be able to install. Now, yeah, you can see now. Now, this is data editor window. And this data editor window has two views. You see variable view and data view. You can see. Look at my, let me use this annotation. Look at it. Variable view, data view. Those are the two views. Return this. The variable view, if you click on the variable view, it's just like you started. We are talking about data and variable. Variable are characteristics, data are the value. So in variable view, that is where you list all your variable. You start with the age, sex, data. But we usually use serial number as first variable because it's very, very important. Serial number is very, very important because when you collect your data, thank God now, you don't use questionnaire number, the advancement in technology. Before, if it is questionnaire you use, as you are entering it, you are supposed to, before you enter, you are supposed to number each of the questions. If they are 400, 1 to 400. So as you are entering, you enter number 1. The reason being that this number you are seeing 1, 2, 3 in SPSS, it does not go into your data, just for convenience for you to see. If you just enter 400 something here now, or 300, you didn't number it. By the time you are running, all this will scatter. If maybe age supposed to be, you just see 7. How can adult be 7? Maybe there's a mistake. Maybe it's 17 or 17. One digit was missing. How do you know what is the actual value? You need to go to your questionnaire paper and look for what is the value. For you to know, how will you know which of them? If you have not number, if you have number it and you have entered the number, when you are running, you sort, you'll be able to know, oh, that one that value is number 36. You go and check your paper and that is, can you see, it help you to clean your data. That's very, very important. Now, that one has gone. Let me just tell you. You will see the variable, the name. These are the characteristics of the variable, the name of the variable, the type of the variable, the width. Let's begin to even do it like that now. Or before I do that, don't let me do that. Okay, I've already shown you this one. If you click on data view, the characteristic of but you won't be able to see it very well until we have entered some variable. We'll come back to that. Before we go, I start explaining that. Let me just show you something about the SPSS environment. Just like any window environment, you will see you see some icon. File, edit, view, data, transform, all those ones. Just like any other, you have some icon that help you navigate to perform some functions. Like the first few, file, edit, view, is like any window. If you go to the Word document, you see file, edit, view. If you go to Excel, so that one file, if you want to save, if you want to edit, if you want to, all those things, they are there. But look at this, those view do some things spectacular, which we'll get back to later. You see data, if you want to manipulate your data, you want to transform, like you want to change data x to x squared now, you want to transform, logarithm transformation, any form of transformation. That is where you want to select, that's where you manipulate. Transform, then analyze. That's if you click on it. Can you see all the functions you want to do? Is it theta? Is it chi-square? Think of analysis. This is where you get the direction. Graph, if you want to plot graph, but most of the time, the graph of XPS is not really fun. Except because Excel produce good graph. So when we analyze, you don't use it for graph. You only get the more information we put to Excel and give. In fact, Starter gives final graph than SPSS. And HAR give the finest graphical presentation. Most of the time, we don't even, whether you use R or whatever, people prefer, okay, when you do your work, you go and use Excel because Excel give you fine graph. You will import to Excel to do your graph. Then this utility are just other things because this package, data analysis is just one of those things. There are other things they do, other product they have, which they can advertise there. Then extension, if you want to do some other things also apart from your analysis, then the window, this one will be very interesting to you. You will see the window, you see something like go to the simulated view window, go to, so this window, if let's say we have created something in the, this one I've already told you that is only data editor window. If let's say we have started entering, we created something now, immediately we save it now, it produces result window for us. We'll be having two windows showing data editor window, result window. For you to navigate between two of them, you come to the window here. But we don't actually do that. If you put your icon on your cursor on the icon on your taskbar of the SPSS, you will see that it's over it. You see the different windows open, which you can click on. Look at, okay, you may not see it, but you may see it. But if you open your own, you will see what I'm saying. Then the last one is split. Split, well, most of the time we don't use it. What that split just for is that where is it? I didn't see it again. Is it that it's hidden? That split, what is it for? Is that many?
It's on that window.
Okay, the other window. Okay, yes, other window. Just leave that one. So we'll talk about it later. I think what I want to talk about is in the other variable window. So this just, and if you come to both variable and data view, it's the same thing. It's just to give you a overview of the type of icon available. Let's now come to variable view. We want to see how do we create a variable. Just creating variable just means replicating your questionnaire on this. It's like, say, put your questionnaire on it. You know your questionnaire, you see, age, sex, marital status, religion, everything, then weight, height, everything you are asking. Have you heard of tuberculosis before? This one. Have you heard of human papillomavirus? This one. All those questions. Think of any question you're asking. That's all your questionnaire. That's what you want to put here. So, for example, now, and I say one, the first one, I see serial number, we call SM, serial number. Immediately, you can be doing that as you are watching, you can be doing on your own. As you press serial, you put the name of the variable, it gives you some default value for all those other characteristics. assuming that you know, some of them may be what you want, where you can change them to numeric. You type numeric. If you click on it, it gives you numeric, comma, dot, scientific, date, dollar, string. What it means that what type of data do you want to enter? That's what it means. Is it number you want to put in when you want to be entering your data? Is it number? Some people, for example, if we say sex now, you either type female or male. That is not number. But if you are typing number, you may say male is 1, female is 2, or otherwise, the other way around. But you know, there is option for string. String means alphanumeric. Is let's call it string. In a pinfo and starter, they call it alphanumeric. Alphanumeric, it means the same thing. What it means, you can write both number and letter. Alpha is letter, numeric number. But this one numeric, only number you can write. If you put in numeric, when you are entering, if you type F, it will not enter. You will not even, it will not take it. Will not even, you cannot type anything figure there, letter there, if you say numeric. So what you want to, and to make it easier, in especially you can code everything. Even you know that for the variable that are naturally number, age, number of children, weight, height, that one there's nobody, it's numeric. So if the value you write is numeric. But the one that are not, like for sex, religion, all those ones, they are naturally categorical. That is qualitative. You can use number. When you use number, you are using number for it as a coding. You will now see what happened later. Now, you now come to width. This width is number of value you can write inside. That is, for example, now, if I say when you want to be entering your data, if you want to type neighborhood, or the value, maybe you are asking for the category of hospital, so we say secondary, primary, tertiary. If you want to actually type secondary, you know the number of characters secondary, can't it? By default, this one will put 8 there. But you can change it, you can increase it, or you can decrease it. So if it is 8, if the number of figure letter for secondary is more than 8, you won't be able to type more than 8 there, more than 8 characters there. So what is the width? That's what it means. Now, decimal, by default, you put 2 decimal places. So we only use, is good. If you are doing something like height in meter now, it usually come in 2 decimal places. But if you want to remove that, you can change into centimeter. In that situation, there's no decimal. So if you don't want the decimal, you remove it. Even this one, you can increase the width. You can decrease it also. Numeric, you can change it to string. Can you see? You can change it to string. Then you can change anywhere how you do. So label, this label, most of the time, the name, when you are putting name, let me give example, age now. Age, let me say age. Let me see age. I want to say age of participant. You will see what will happen. Of participant. You will see what happen. It give me error. It doesn't allow you to put gap. So if I now say age and put underscore, it will not allow you to put dash, because dash is minus. It's operational something. It will not allow you, because it's one of these things they use in the software. Yes, the software for analysis. The underscore, that is shift dash, it will allow you. Or me, I don't like that. So I usually say, okay, leave age alone. Sex, marital status, marital status. marital. I will not, you won't put graph and not put status, make it capital. Just to read. But if you want to put, you can put underscore there. In between, it will take, but it will not take gap for you. Does it make sense now? So now, but when you now come to label, you can actually see age of participant. It allows you to write. And you see age of participant. And you see sex, you can say set of marital status. Look at it, marital status. Allow you to put gap. Right. So the essence of this one is that, especially if you are doing your work now and you want somebody, you want to send somebody to analyze, or somebody is doing work, you want to send to you to analyze. If you type all those things the way the question are, it make it easy, natural for the person to see very well. Okay, this is the way he has the question. The more the person that want to analyze know, is the closer to the way your questionnaire is, the better is to understand, to be able to analyze. Likewise, you want to analyze for somebody, if they label it very well. Me, I don't like in the sense that in the when you are running it now, is this label that will come an age of participation marital. But me, I prefer this one. So you may not label. Me, I don't usually label. You may not label. If you don't label, the way you write, it come out. But if you label, it's the label of it that will come out. Does it make sense now? Now, this value, what does it mean? This value, if you click on it, you see, in a situation where or any variable that is numerical, you put the value there, no problem. You know, you say numeric, age, number of children, weight, height, family size, all those are number. But when you say sex, you say it's numerical. It's go to 1 and 2. What does 1 mean? What does 2 mean? That's what we call value. So here in sex, our one may be male. You now say, you now click it there, see, value. When you are creating your question, you say, sex, value, 1 is male. You now say, 2 is female. Does it make sense now? So that one also, it give you, if you look at it, the decimal by default, you see 2 decimal places. That's why it's giving me these 2 decimal. So if I don't want it, you reduce that decimal to 0. You don't want to see decimal. Any of if you want to see. Can you see now? I click on it now. Can you see? So that is when I'm entering that, I just enter 1. We don't 1 mean male, 2 mean female. The same thing with marital status. You see, 1 means single, 2 mean married, 3 mean separated. As many as you want to put. 4 mean divorce. 5 mean widow. Can you see? You're done. You see? So now, missing value. If you click on missing value anywhere, it will give you something like that. It gives you 3 options. You know, the logic behind missing value is when you administer your questionnaire, there are some non-responses. They don't answer some questions. And there are many reasons for not answering questions. Some people now, they may not answer the question because that question is not applicable. You say, have you heard of tuberculosis? So we say no. If you have, what's your source of information? The person that say he has not had cannot give you source of information. So he will not tick it. Or the person that is administering will not ask that question. The value will be missing for that person. Some people, they don't know. If there is no option, I don't know there. The person don't know, we leave it blank. Some people, they just decide not to, it's really not respond. They decide not to answer some question. And you see, there are many reasons for missing value. So that's why the SPSS, they are done in such a way. They use two methods. You can type the number, they always say, okay, they give you category. This category you can create about 3 for the, because we have different reasons. I may say 99. Why they use figure? You remember, you that are doctor, whenever you are doing percussion, you say 99, that one 30, that 99, you know. So, they are just using high tone, something that can vibrate. But this one is not the same reason. The reason for using 99, 99, is the highest figure when it comes to when you talk about figure 1, 2, 3, 1, 2, 0, 1 to 9 are the figure, the real figure. But it's just adding it to get 21, 21, so it's really the same thing. So the highest one is 9. We just use 99 because we use it for looking for a figure that will be outside what you are given before. For example, now, if I want to do missing value for marital status now, and now say I want to put a value. If I go and put 5, you know that one of the option here is 5, widow. So anybody that is missing, you put 5 here, if we count the person as widow, you must put a value that is outside the one you are using, any value you are using in the value of the variable. If you want to do missing value for age, if you go and do 99 and somebody is up to 99 in age, so that missing value will count that the person is 99 years old. Are you seeing now? So that is why if we want to use missing value for age, we know that someone may be up to 100. You can say 999. Are you see now? You just look for a figure, or you just look for a figure that is high enough, that is outside the range of possible value for the variable. Now, when we say, okay, we will say 99, and this one say, the second one 999, the third one 9999. What is just for us to separate for, okay, when you are entering into anybody that is not applicable, I'll put 99. Anybody that don't know, 999. Reason for the missing value. Anybody that, okay, anybody that is 999, then maybe the person didn't just make it blank 9999. That is, it's just for you. But it's not everybody that use me. I don't use it, to be sincere with you. I don't use it. So here, if it is the third option, the first option default is no missing value. That's what I use. No missing value. Because even if there's any missing value, the SPSS run it for you separately also. The frequency will be have missing value. It will give it to you. But maybe it's useful for somebody that want to separate the reason for the different type of missing value you have. And you may employ and use. Or you can come and use a range that you're going to give a value between this and this, from low to high. You just say any value that is between 7 to 15 or 20 to missing value. In that situation, when you are entering, you just give any value in between. It's a missing value. Now, I don't use missing value. That is it. So it's just there. There are a lot of things that you may not even need to know there. This column, I talk about which the other time when you want to enter something, but this column, the name of the variable itself, if you don't, even the variable itself, if you like my status now, if I put the number width, as I put my status, I now say maybe the column is 4. If I type it will not take it. It will just take MAR. So it has limited. It will not appear. Let me see. One of them is value, one of them is, let me even do it so later. So when you now go into when you start analyzing, you will not see this is MAR you're going to get. You cannot you cannot see all the name out unless you increase the number of the column. So can you see one is the number, the number of the letter for the name of the variable. One is the number of the data, digit of the data you can enter. You get to appreciate it better as you are doing it. Why alignment? It's just like any alignment. No alignment is either right, left, or middle. So but one thing that by default, if the type is numeric, if by default it gives you right alignment. Let me, for example, let me change this sex to, let me change the age, or let me say the numbering, serial number to string. Can you see? Automatically, the alignment change to left. When the type of variable you are entering, the type of thing you are entering is, you make it string, alphanumeric. Alphanumeric can enter number, you can enter the letter. But you cannot use that number for calculation. For example, now, if you put age, string, it doesn't stop you from, you can enter your age, but you cannot, when you say you want to calculate the mean age, you will not see it. Because it's not, I don't know if you understand me now. That is why normally everything you just put it as numeric. That's why we are going to code. So the alignment, there you can change it with hand. It doesn't matter. Even if you say numeric, you can decide to say alignment is center. You can change it with hand. Doesn't change anything. It's just for the way it will look like. It doesn't really matter. Then me and the measure. This one is scale of measurement. The scale of measurement we just talk about now. Is it nominal, ordinal, or they collapse the interval and ratio together as scale? So is either nominal, can you see, ordinal, hierarchy, then scale. That scale means number, that is either interval or. So you have to see, because when you are doing analysis, the computer has a way of generating statistics based on the type of statistics you are dealing with. For example, now, all this one, they are nominal. Then age is numeric, is scale. Is scale rather. So this one, it doesn't really matter. Serial number, because you are not using for any calculation, just a serial number. You can leave it at number, it doesn't really matter. But age is scale. Sex is nominal. Ordinal. Then if we come, marital status, ethnicity. Ethnicity is nominal. You see, it's unknown here, it's a nominal. Now let me go to the last one. Row. That's why I was having that split. Row here, if you click on that row, for example, now it gives you input, target, both. No, we don't use it also because a lot of things they are put in that, because a particular operation can be performed in different way in these spaces. So it makes some of those things even there, you may not even use it. You input by default, you say input is input, row is input. That is, it's just one of the variables. But you can use the variable as a split variable. For example, making on it. Split. If I want to, you are doing maybe you want to analyze based on sex, male and female separately, you split it. If you run male, so that sex will be split, but there's no need for that, because if you want to do that, there's a place where you analyze it, it can give you. If maybe you can set it for split, if maybe you are doing comparative study, there are two groups, rural and urban. Ab initio, you are going to analyze them separately. You can see, because in that situation, there will be a variable called group. For example, now if you are having more than one group, after serial number, I can create a variable. Can you see that? If you want to create a variable, you insert, you right click on the number, this last first column, above for the row above where you want to create variable. For example, I want to create variable after serial number. I click serial number is number 1. I will now click on number 2, and I say insert variable. You give me, can you see that? I will now say group, because I know my study will have urban rural. And I say, I can say here now the value is 1, urban, or rural. Because rural is arrow, arrow before you. Rural, 2, urban. Can you see? So you can make it 1 decimal, no decimal place. Can you see? So it's still nominal. So you come to ethnicity is nominal. Which one? Education level. Okay, religion. Religion. No, you can come and put it here. Religion for ethnicity. See, 1 is Hausa, 2 is Igbo, 3 is Yoruba, 4 is others. Then you know this one is applicable most of the when you are doing your study in Abuja, Lagos. But if you are doing your thing in, for example, now you are doing in Benue, you are likely to see a lot of thief and Idoma. In that situation, those are the ones that will be there. You may see half all this one. You say thief, Idoma, Hausa, Igbo. You may not even see more or all those other ones. You can say other. Based on the number you see, you can say other. But when you are dealing with, you are doing all this in here where we have natural capital like Abuja, Lagos, where everybody is, you will discover that based on the population, whether you like it or not, those are the major people that have been major. So you put it like this. But in some situation, you may not see one thing good that is a little bit prominent. You can add it as a separate group. You can put others. That's the way to do. Religion, you can say 1, Christianity, 2, Islam, 3, traditional. So, yeah, you can reduce all this. Now, let's now go education, level of education. So, you have, this one is ordinary now. 1, no formal education. 2, primary. 3, secondary. 4, tertiary. So its level of education is not, some people come, they say Islamic, Islamia, but it's not the, if you want to put that Islamic education, that which level is it? Because in Islamic education, you have primary level, you have secondary level, you have tertiary also. So you have to, is the level of education, because it can be confused. Some people now put Islamic number 5. If you put number 5, ordinary, you are trying to say that as you are ranking education from normal, so Islamic is now after tertiary, and you not say it's ordinary. So it's ordinary. So it's ordinary. Ordinary means that it's in hierarchy. So if you have something like that, you put it, that Islamic education, if it is primary, put it as primary. It's the level of exposure of that person. It's not the what the person read that matters in education. It's the level of exposure. Because I believe that everybody that have secondary education, you think differently from people that have tertiary should think. So that is like, what level is it? Now, then occupation is another. Occupation is another ordinary. So mistake people make here, they just say civil servant, that one's useless. If you say civil servant, so if you want to do your occupation, it's better you go and use what we call registered general classification. They rank, because occupation has category. They rank occupation from lowest to the highest or highest to the lowest: professional, intermediate skill, manually skill, non-manually skill, manually skill, semi-skill, partially, partially on skill. You have about 6 or 7 categories like that. You do use it, and it's going to be ordinary. But if you go and put a civil servant, businessman, so a doctor, engineer, accountant working in government is civil servant. The cleaner working there is civil servant. So can you see? So you see that there are different, there will be interlock. So it's better, there will be, what do I call it? It's not mutually exclusive, but if you use the right calculation, it's going to be ordinary. You code it also. Now, let's now come, these are social demographic usually encounter. You say something like yes or no. Have you heard of, HPV? HPV. So it's either yes or no. So here you just say 1, yes. 2, no. You can use 0, no. Depends. Then you can decide to say 1, yes. 2, 0, no. Whichever one. Whichever one. So you remove decimal. So can you see? Now, there are some questions that require multiple. For example, what are the symptoms of cervical cancer? When you have that question, symptoms of cervical cancer, you will list about many symptoms. Take as many as possible. In that situation, one question, if you go and put, symptoms of cervical cancer, symptoms of cervical cancer. You now think, you now say 1, you giving me, you now say 1 is bleeding, vaginal bleeding. Sorry. 1 vaginal bleeding. You now say 2. Which other one? Vaginal discharge. You now say 3, dyspareunia or pain at intercourse. During intercourse. Now, the problem you're going to have with this arrangement is that somebody may click everything. He knows that all these 3 are symptoms. So at the end of the day, they can only choose 1. If that's the way you have this, some people they discharge, they do their this thing like that, and they mess in the workup. So each of them is supposed to be yes or no. So what you're going to do is that you may say symptom of cervical cancer. Instead of putting the symptoms, you can say symptoms, but that vaginal bleeding is here you put it. So symptom, discharge, pain, symptom, pain. So all this one will be yes or no. Can you see now? Whenever you have multiple something, each of them you treat it as a question. You create a variable for each of the option for them to go yes or no. So that if anybody, whichever one they put, you put yes. The one they say no, put no, 0. You can use here 2, 1, 2. You can use 1 and 2 or 1 and 0. So that's the way to create it. So the last one, all these one, they are nominal. Whenever anything yes or no, they are all nominal. Anything yes or no, they are nominal. Okay, I will do that one later. Now the last one I want to. What happened? Yeah, sorry, it's just something here. So the last. Okay. Any question? If you have question, you can ask your question. Okay, don't worry. Now, the other one I want to. Is something that requires weight and height. Weight. Yes, somebody raising hand. Ask your question.
Yeah.
Bali.
My question is on groups. When you were speaking about the role of the data, you said we might not need to change it. We can use inputs, but where we have two groups, like the one we have here, rural and urban, we can use the split rule. My question is, what does the split rule do when we have to use different groups?
Okay, I said that you may not even use the split rule also. When you are analyzing, I say you can use it when you are analyzing. I don't use it. I don't use that split variable. I don't use it. I just leave it like that. So what it does is that if you want to run the analysis, if you are doing two groups like rural and urban, you want to run all your analysis separately for each of them. You will know if you don't split it. Imagine now you have 200 rural, 200 urban, making everything 400. You just run the analysis, everything, mean, ethnicity, everything, 400 in one place. I don't know if you understand me now. But if and you want to do it for separately for rural and urban, that is the split. It's the split that will help you split it. But there's no need. Even if you don't put a split, there's a way when we start running the analysis, I will show you how you under the data here. You can do the splitting. We'll still do it. Is it clear now?
Yes, it's clear.
So the last one is weight. I want to weight. So you know this weight, well, you may have one day, some people, they measure weight to decimal place, you can maintain one or no. But definitely if you have height in meter, if it is meter, you know that it's going to be 2 decimal places. But if it is height in centimeter, you may not put the decimal. So I just wanted to see how the decimal place can be, how useful the decimal place can be or should be or whatever. Any other question? Okay. Now, after we have done this now, go to data view. Can you see? Farouk, ask your question. Farouk, go on.
Sir, my question is regarding the values. You said for qualitative data, you can simply put the value and the label. For example, 1 male, 2 female. What if it's numeric data? Will you just leave it as none?
Come again.
These values. I said these values. We have 1, for example, 1 and the label is rural, 2 the label will be urban, or 1 label is male and 2 label is female. Those are for qualitative variables. What if the variable is quantitative? Will you just leave it as none?
You don't label, and that I told you don't label now because the essence of labeling is something that is no number. You want to type number there, type of variable. Naturally, it's not a numerical variable. So you only do labeling for those ones that are categorical that you are using numerical for. I don't know if you understand me now. So something like if you look at
Yes.
weight and height and age, they are number naturally. If you look at it, I didn't put category for them. I didn't put value. It's only occupation I have not put, which we can put also, not that we cannot put. Is it clear now?
Yes, sir, it's clear.
Mm-hmm.
Thank you.
Okay. So why is this thing splitting like this? So look at our this thing. Why did I press that this is splitting? Okay. So look at what we have here. You see, immediately we change to data view. You see it has populated. If you remember the variable view, the name of the variable is along the horizontal. The characteristic of the variable are along the vertical. Yes, I'm now. So that if you have 15 variables, now can you see we have put up to 15? Though they actually 40 because serial number we just put as number 1. The even group also is just a group. They are available from number 3. So that's that we have about 12 variables we have entered, we have put in. But of course, the list, this is just for demonstration. In the list, you go to create all your question, everything there. So when you now come here now, you see that the variable name that the variable that are horizontal, they become those name, they now become vertical. Can you see now? So what you now have along the horizontal now will be the cases. That is, if you have 400, your sample size 400, you just put number 1 person, you enter. That's how you are going to enter to, you know, we have already put serial number. The first one you put 1, you begin to enter that person, which group is group 1 or group 1, whatever, what age is 56, what is the sex is female, which is 2. You know, you begin to enter like that. You begin to enter. So when you enter everything, you come here for number 2, you enter. If they are 400, that's why you go to have up to 400. Up to if they are 300, does it make sense? Any question? What's the time? Because this thing, if you are doing it, or I can share with you that go and populate this one, but you can do that and populate it. Because by the time we want to start running, I have data set I've shared with you, we are going to use. But this one just to demonstrate how to do it. So you can lay your hand and try to create and enter and save. So if you want to save now, look at it. I will just say file, save as. I will now look for where I want to put it. So this one is under the data file I share with you. This is where you want to share it. Let me just, what is it called? Demonstration. So you can go click on the maneuver through your folder where you want to go and save it here. Maybe you have created folder for your research, your document. You can go there and put it, not that you just save blankly and say you don't know where you save it. You can decide where you save it. When you want to open it again, you don't even need to open SPSS again. You can go to where you put it and double click it. You open it for an open SPSS software for you automatically. That's one beautiful thing about SPSS. Any question? So this after 10. So I think we stop here. Let me stop recording. I didn't even know that we'll be able to do as much as we have done now. So I think you have tried for tonight.